Hey, we're going to do a quick overview of steppers. We're laughing like giggling children because we've had some feedback about our audio quality, and so we've come up with this solution, which is a wireless mic currently held in a pair of tweezers. I don't know how sensitive it is. But anyway, just let us know if this one's any better than the...
Oh my god, it's redlining.
Let us know if this one's any better than the previous one. We're going to have to do a lot of editing on this. Anyway, we're going to do a quick overview of stepper motors. We used them in our gantry robot project, and we're just going to show you basically what we learned and the sort of the quick start guide to how to use them. So there'll be a link to our gantry robot project video in the description, and you can see the timestamps for this video on screen now.
Yeah. Right.
Hopefully. Anyway, over to us in a minute. So we're going to start with this, which is the stepper motor out of a 3D printer, out of a Creality 3D printer, and this is the driver board, which is actually a brushless DC twin motor driver board. These work because you can drive DC motors forwards and backwards and independently. So these come with these cables sometimes. We've got one of these, which is a sort of 6-pin output on the motor, but only 4 of the pins are used. So the motor housings are built for both 4 and 6-pin motors, and we've got a 4-pin motor here. And this just steps that down to a 4-pin sort of socket on the other end of that. And you can see this little bit of white tape is indicating which side is the A channel there. And so we can then wire that basically directly into this driver board. I'm just going to get some wires, and we just go around the wiring of the driver board. So this is output 1, output 2, so on. We'll put this into fast forwards to get through this bit. And from here, we can then look at these pins at the bottom. These are called enabling pins, and this threw us out for a long period of time with these driver boards. Those pairs of pins need to be bridged for this to work, which is actually quite annoying. So you get these little clips, and they just go on there like that, and that essentially bridges those pins and enables the motors. So make sure you've got those on your driver board if you're using one of these. We've just put in the power cables there, you can see, into the inputs, and then we're going to wire all of this up. So we'll go round here and put our cables from our motor driver into our cable for our stepper motor, and obviously this is a bit dirty, but this is just to show sort of how you do it. So there we've got output 1 in channel A and output 3 in channel B, and then output 2 into channel C, and output 4 into channel D, and that's because of the way the coils are paired within the stepper motor. So that's why we do that. And it's a bit messy, but you'll be able to see it working. So then to wire up the other side, the control side, we've just got 4 cables here. We're going to plug them into our Arduino. This is channels 11, 10, 9 and 8 of the output of the Arduino. And that goes directly into our driver board as the inputs 1 through 4. And you can see that there, 11, 10, 9 and 8, 1 through 4 on the driver board. And then I'll hand this over to Ethan to do some coding. Everything else is wired up. You can see the power is on there. So we've just got some power to connect up, and the Arduino will be connected up by a blaster cable. The power for this is running at 1 amp and 10 volts.
Okay, so here I am just declaring my constants for channels A through D. A, B, C and D. I'm going to be declaring them to be 11 through 8, where 11 is channel A and 8 is channel D. I'm then going to declare a variable called step, which will keep track of which step I am at in the stepper sequence. Here I am now writing a rotate stepper function, which will take in the direction and the step. Here I'm just declaring from which direction you're moving, for which direction in the step sequence do we want to go. So at the moment I have direction equals 1, use step plus plus, and if it's greater than 3 you essentially reset. However, I'm going to change this as I wrote it the wrong way around. And then also for the second if statement, I'm going to just get the edge case to reset it back. And now I'm going to be writing the each stepper configuration. So I'm just going to use a quick case statement for the 4 different configurations, which I'll have on screen now as I write them. So here I'm just writing the delay that I want for this. Now the minimum delay you can have is roughly 1 millisecond, although 2 works slightly better. Anything longer than that and it's just too quick for the motor to actually. And now here I'm just returning the new step for it to iterate through. And now I'm writing the standard setup function for Arduino, which I'm just setting all the pin modes as an output. And now I'm just writing the void loop, which is essentially just step equals rotate stepper. And then here I control which direction it goes. And I have a small little issue where I'm missing a semicolon, and that's it. Here you can see that when it's -1, this means anti-clockwise. And if I just run it, you can see that it's running anti-clockwise. Now, nice one. And then if we just move that to a +1 and rerun that, that's now going clockwise. And here if I just change the delay slightly to 10, we will see that this moves quite slower. And here I'm just showing that this is clockwise. And now if I put this back to 2, it goes a lot quicker.
So now we're going to talk about 5-wire steppers. So these are essentially 6-wire steppers with a common ground, but these are the ones that come commonly in things like Arduino kits or sort of microcontroller starter kits. So you can see here we've got 3 different driver boards. All these driver boards are the same chip, they just have different styles on them. Some of them have sort of LEDs, like these are through-hole LEDs on this, and we'll use this one. This is what comes with the Arduino starter kits. But the other ones also have sort of basically the same thing. And there's the stepper motor we'll use for this, and the wiring is exactly the same. We just put the 4 wires into the ins on this driver board, and then we have the power supply which goes in the bottom there, and we'll plug the stepper motor in, and that's literally it. The rest of it's done in code, so I'll hand it back to Ethan.
Now with the 5-pin steppers, it's essentially the exact same code. However, instead of the step being greater than 3, it's now greater than 7. And then now, instead of the 4 cases, there's now 8 different cases, which I'll show now. The diagram will be on screen as well, just to show the different setups, and it works the exact same. So here if I just set delay to be 10 and I run it, this being clockwise, it is moving very slowly, but you can just about see it, and you can see that on the LEDs there. However, here I've just sped it up, delay 3, going anti-clockwise, and as you can see it's now turning anti-clockwise. much, but delay 1, still going anti-clockwise, but it's going a lot quicker.
Seb from the future here. Whilst editing this, I realised that we didn't actually talk through sort of the fundamentals of steppers, so I just thought we'd go over that quickly in case it's of interest. So this is how the steppers are sort of orientated inside. There's a series of coils, and essentially what happens is it increments through those coils, powering each one individually to move that north pole of the magnet to the on coil. So here it's the fourth coil that's active. As you can imagine, when you power up the third one and both of these are on, it's drawn halfway, and then when you power off the fourth one, it's drawn to the next step. And that's essentially how that sort of works. There are lots of different types of steppers. Unipolar and bipolar are the two that you'll come across most commonly. Unipolar have 5 or 6 cables. We've got sort of some examples of those behind me. 1 second, please hold. This is the one from the video, which you've seen. You get really, really small ones. That one's actually only got 4. And then this is a 6 cable stepper. The main difference for steppers is due to the way that they're wired. So a 4-wire stepper has 2 coils or 2 pairs of coils with no center tap and requires a more complicated driver. However, it provides more torque than bipolar steppers. And 5-wire steppers have 2 coils with center taps, or 2 pairs of coils with center taps, that are connected together and are essentially unipolar steppers. Alright, so that's kind of it for today. This has been a bit choppy and changey. We're halfway through doing quite a lot of coursework. We've got quite a lot of deadlines this week and struggled to get the time together to basically keep making stuff. But should all be back to normal soon, and we've got a new project kicking off next week. We start the new project?
I believe so, yes. I believe so, yes.
This is a bit like conducting an interview. I don't think this works very well. We need to find another way of doing this. Anyway, that's it from us today. That's it from us for today. Let us know how the sound quality is compared to previously, and let us know if there's anything you want elaborating on or anything like that. I'll say goodbye. See you soon.
Bye for now.